Okay, good morning. Fix that. So we are on day 3. All right, day 3. We're going to do chapter 2 today in your book. I've also got some announcements to make. So I made a Dropbox for your assignments. This is or for your lab assignments, I should say. So if you go to assessments and then assignments, you'll see the scavenger hunt was listed here, and looks like somebody has already submitted one. So you ought to be able to go in there and submit your lab report for the scavenger hunt. We're not doing a lab today. I'm kind of feeling under the weather. I don't think it's COVID related, but nevertheless, I didn't get much sleep. My brain ain't working right. So that's why this video is a little late. It's also why we're gonna do two reasons why. So we're not gonna do a lab today, a full lab. We're gonna do a full lab tomorrow, and I did that because I wanted to make sure that we covered all the material that you're gonna need to do the labs. We still haven't talked about anything chemistry related. Essentially, we've just been doing math. So we're gonna wait till we cover chapter 3 tomorrow's lecture, and then you'll have the lab ready tomorrow afternoon. All the labs are due by Sunday at midnight, and then all the master in chemistry, which there will be 4 that will be due by Sunday at midnight as well. Okay, so I don't have a link to those assignments on Cougar View. If you haven't been seeing those, it's because they're in Master in Chemistry. If you go to Master in Chemistry, enter in the course ID. It should be on the syllabus or in one of the earlier videos. I can't remember. Enter in the course ID, and it will take you to course homepage. You can find the assignments, and then it'll show you. Now those take a little bit of time. I haven't seen, but some people spend a lot of time. Make sure you stay up to date on those. Get them caught up. If you try to do them all Sunday, you probably will run out of time before it closes out on you. So try to stay up to date on that. It's better just to go ahead and knock it out each day if you can, right after you do your studying, and it's fresh on your mind. Get in there and knock it out. All right. Those also take a long time to grade, so the sooner you get it in, the better it is for me. If you're going to be, concerned about knowing where you're at in the course and up-to-date grades, I'm going to try to catch up every weekend and have your grades ready coming into the next week. So it'll be a week lag, obviously, but that should keep you kind of informed about where you are in the course. All right, let's see what else. Other announcements we have. For the syllabus, I'm going to update the syllabus for the lab. I'm still figuring out which labs we're going to do. So it'll be a tentative schedule. I'll put up what chapters we're going to cover in lecture and what labs we're going to do throughout the course. Tentative, so those could change depending on how fast everything goes. So I'm also going to do PowerPoints. I should have the ones for chapters 1 through 3 up by Friday afternoon, so that you'll have them all ready for the weekend. I'm not sure how everybody's schedule is working. I have another job, so I try to I'll probably be doing most of my work over the weekends. I'm going to try to get ahead next weekend, so you may have a couple videos that I'll stack up and then release daily, so that I can be on top of grading and all these other things. Let's see what else we have. So today I'm not going to be doing as much lecturing. So typically when we're in person, I would spend about 2 hours lecturing. I'd send you on your way. You go do your homework every night. I mean, the summer courses are intense. You have a lot of work and you spend a lot of time doing this stuff. But I imagine when you first signed up, you saw the schedule was 4 days a week with 3 labs, and you knew what you were signing up for. So it's not a regular online course in the sense that you can just kind of do it whenever you get time. If you don't stay up, you'll probably fall behind and you'll probably won't get some of the stuff turned in. And since almost all of your grades come from these assignments, it could definitely impact your grade. Yeah, so usually I'll do 2-hour lectures, but in this instance, I'm not the best at videoing and using these technologies to teach, so I'm gonna put some YouTube videos up today that I really liked for scientific notation, converting units, unit conversions, density, and significant figures. Okay, so that's some of the sections that we're going to cover in chapter 2. I will go through there, and I want to show y'all a couple of things on my whiteboard here that I think you should be familiar with. They partly go into it in some of the videos, but I just want to show you how I do it so that I think it makes it easier to decide what's the right way to do the math. And as it was yesterday, a lot of this is math intensive, so just bear with me. We'll be getting into chemistry really soon. Okay, so next up, let's go to the book. All right, so units of measurement. In America, in the United States anyway, we use the English system, which is inches, feet, pounds, and miles. All right, but around the rest of the world, they use the metric system: kilometers, meters, liters, grams. And for the scientific community, we all communicate with each other, we share information, results, and it's easier if everybody's on the same page. So the scientific community has adopted this Systems International. That is the International System of Units. It's mostly based off the metric system. There are some differences. For example, Celsius and Kelvin, you'll see both in this course. Yeah, so we're always reporting using the metric system. There may be some conversion problems on Mastering Chemistry that deal with English to metric and metric to English or whatnot. So I'd practice those. But as far as reporting, you always report in metric or SI. All right. So volume is the amount of space a substance requires. 2-liter bottle, right? The amount of liquid in that bottle, or the amount of space within that bottle, is 2 liters. It's probably not actually 2 liters worth of liquid. And then they're expressed, you'll see it expressed in multiple ways: milliliters, liters, and that is just conversions using the scientific notation that we were talking about. I'll do some more. That's what I'm going to do on the whiteboard, but I want to cover other things before I get into that. Okay, so we talked about temperature. You'll see Celsius and Kelvin. You may have to convert from Fahrenheit, and I can show you an equation to do that. Yeah, it's good to know. It's good to know. It's like 9/5 plus 32. I think they might actually use 1.8 in the... Okay, I thought it was right here, but it must not be. You'll have some practice problems on that, but it also provides the equation. So as long as your math is tight, shouldn't be a problem. All right. Let's see. Grams, kilograms, centimeters, meters. So meters and centimeters are what we use for the length. Mass is done in kilogram and grams. And it's important that you always use those units because a lot of the other characteristics are defined by those units. For example, density is the mass per volume. Always use a metric system. You'll use grams per milliliter. Okay, so it's important that you know the metric system and use it for your masses and your volumes rather than using gallons or inches. You'll use liters and centimeters. All right. So There's some good practice problems here, but you're going to have plenty on mastering chemistry. All right. Okay, so this is interesting. I want to talk about measuring. All right. So there's certain little rules to how we measure. All right. So let's look at this ruler here. Okay, right here. So this ruler falls exactly on the 3, and I can estimate that that is pretty much 3. We like to have as many significant figures as possible. Significant figures, this would actually be a good point to pause, go to the significant figures YouTube video, finish that, and then come back and carry on. That way you'll have a good idea of exactly what significant figures is. So we like to have in science as many significant figures as we can. On this ruler here, if I was putting this in my notes, I'd say this is 3.0. Okay? Now, I don't know that it's exactly 3.000, but it's so close that I could estimate and then add that significant figure. Now, this only really works in the graduated measurement. So, graduated cylinder, a beaker, and you'll get more familiar with when it's okay to do this and when it's not. All right. So, I would call this 3.0 centimeters. All right. That gives me an extra significant figure that I can use in my calculations. All right. For this one, since it falls directly between the 4 and the 5, I'd estimate this one at 4.5 centimeters. Okay. Now I wouldn't, if it falls in between, say, 4.2 and 4.3, I wouldn't estimate doing 4.25. You're really going a little too far by adding all these extra significant figures when you're really not sure if it's closer to 4.3 or 4.2. Okay, so if it's in the middle, if it's in between, say it's more than 4.2 but less than 4.8, right? So like right here, it's definitely more than 4.2. It's definitely less than 4.8, which would be around here somewhere. I'm going to call this 4.5. I got one extra significant figure out of it, which is definitely helpful, but I also didn't stretch it too far to make it where it could be inaccurate or falsified results, right? All right, and so looking at this one is got the smaller graduations in between the centimeter. So on this one, I would estimate it at 4.6. And if I can really get down there and look at it, I can use that same technique that I just used for the larger increments on the smaller increments. So say the ruler falls directly on top of the 4.5 line, then I could call that 4.50. If it falls directly on top of the 4.6 line, I can call that 4.60. And if it falls directly in between it, I would call it 4.55 centimeters. All right. So those are little techniques that you could use to increase the number of significant digits. It also helps you get more accurate measurements. I don't know if any of y'all work in construction, and I do. This was actually really helpful for me getting exact measurements and coming down to when I'd subtract or add or multiply, having the exact measurement or a closer approximation of the exact measurement means that when I multiply with another close approximation, my final answer is even closer. And that's what significant figures does for us. It allows us to get as close as possible to the true answer. All right. So, significant figures, make sure you watch that video. All right. So here we talk about scientific notation, significant digits. So you're going to want to look at the significant figures and the scientific notation videos at this point. And then the significant figures video will show you how to determine how many significant figures will be in your final answer. Typically you use the whatever your problem is, whichever number has the least amount of significant figures, that's the number of significant figures that you'll use in your final answer. Okay? There's also some rules for rounding, which kind of goes back to what we were talking about with the ruler, right? There's certain ways to round that are accepted and certain ways that are not. Okay, so this is what I actually want to work on my whiteboard. Okay, so these are the conversions. So you'll hear millimeter versus meter, or centimeter versus meter, milliliter versus liter, and you're going to need to know how to go back and forth, because when we do, say, density, for example, it's always expressed in grams per milliliter. Okay, so if I give you a problem that expresses a mass in kilograms, you'll need to convert that to grams before you can give me the density. All right, so it's important to know how to do that and how to go back and forth. So let's bring up my whiteboard and let's do a couple problems that I want y'all to see. Like I said, it is very good if you've already seen the significant figures, scientific notation, and say converting units videos. I think that'll help you get through this much easier. All right, let me pull this whiteboard up. All right, so for, let's say an example would be 5.62, let me get this more stable, sorry, micrometers. That's a micrometers, and I want you to tell me how many meters. This is still not stable. Give me a second. Okay, everybody can see that? Good. So the first thing you're going to want to do is write down the conversion between micrometer and meter. So if I go to, let me show you this, transition. All right here you'll see that micro, this little symbol mu, right, is equal to 10 to the negative 6th of the base unit. In this case we're talking about meters, so a micrometer would be 10 to the negative 6 meters. All right, now if I were going to turn meters into micrometers, I'd multiply that times 10 to the positive 6th power. All right, so let me go back to my board. The conversion for a micrometer to a meter is 1 micrometer. Dadgummit. Sorry, my board is not wanting to cooperate right now. Let's try this a little bit bigger maybe. Okay, so yeah, 1 micrometer is equal to 1 times 10 to the negative 6 meters. Okay, now because these are the same thing, that actually equals 1. All right, let me write it the other way as well. There's actually several ways I can write this. So let's do 1 meter is 1 times 10 to the 6 micrometers. Okay, that also equals 1. All right, so now what I want to do is I want to choose the one that lets me get from micrometers to meters. All right, so I want to multiply this by one of these here so that micrometers cancels out and meters is left on the top. Okay, so that only one where meters is on the top would be this one. So let's do that. Clear this. All right, 5.62 micrometers times, let's throw that over 1 just so everything's in a decimal, time, clear that. Times And we said that 1 meter is equal to 1 times 10 to the 6 micrometers. Okay? So, then my answer would be 5.62 over 1 times 10 to the 6. My units cancel out. The only one left is meters. So that'd be, oh, I did that. Meters. Okay? Now, when the exponent is on the bottom, like this right here, 10 to the 6, you can actually just move that exponent to the top and put a negative behind it. So it's 5.62 times 10 to the negative 6 meters. Let's get rid of all this. And this is your answer. Whoop. That's your answer. Okay? Let's do another one. And I want to show y'all on a calculator so that I guess it's clear off. Okay. Let's do another one. So 465 kilograms. I want you to give me that in grams, right? So we go to our table. We see that a kilo is 10 to the third of the base unit. Okay, in this case, grams. So a kilogram is 10 to the third grams. All right, let's go back to our board. So 1 kilogram is equal, I'll do the 1 times 10 to the third is the same as 10 to the third, right? Grams. Or we could do, let's write it in just the regular number, 1 kilogram, 1,000 grams. Okay, we can do it over the other way, so 1,000 grams equals 1 kilogram, or 1 times 10 to the third grams over 1 kilogram. Okay, so you notice that you will see both. You'll see scientific notation, and then you'll see numbers written out. So you're going to have to be able to convert, use them in equations, use them in a calculator. All right. So let's decide which one of these we're going to use to solve for gram. So what you want to do is figure out what can I multiply this by to cancel out kilogram and end up with just gram. So going down through here, the kilogram is on top. If I want to cancel it out, I need to pick one that has kilogram on bottom. So that takes care of those, are no good. All right. So now both of these, the 1,000 grams and 1.3 times 10 to, or 1 times 10 to the 3 is the same value. So these are technically the same. I'm going to use the 1,000 for now, but I'll show you why here in just a second. So 465 times 1,000. Let me actually clear this so y'all can see it written out. Okay, 465 times 1,000, 65 kilograms. I'm going to add over 1 just so I can see it. All right, and then we said 1,000 grams over a kilogram. Multiply that out, and you will get 465,000 grams. Okay? 465 kilograms equals 465,000 grams. All right, so let me do what happens if we pick the wrong conversion to begin with. Okay, so let me clear this. Say I started, but I accidentally chose 465 kilograms. I accidentally chose the one where the kilograms didn't cancel out. Okay, so I chose the one that was 1 kilogram over 1,000 grams. All right, now when I go to multiply this out, you're going to see that my units, 465 over 1,000, And units are going to be kg times kg, right? So kg squared over a gram on the bottom. So 0.465 kilograms squared per gram. That doesn't mean anything. So that's how you're going to know if you went the wrong way. If you end up with units that doesn't match what the question's asking for, then you've done a conversion somewhere along the way incorrectly. Okay? So I want to show you how to do some on a calculator, just so that you see how inputting scientific notation can affect your answer. So one of the toughest things about these conversions is deciding which way to go, right? So if I'm going from a liter to a milliliter, right? So a liter is larger in size than a milliliter. So when I go from liter to milliliter, the number is actually going to get larger. Let me show you what I mean. Okay, so 1 liter is equal to 1,000 milliliters, right? A liter, let's just guesstimate, a liter in size would be this. A milliliter in size would be this right here, okay? I can get 1,000 of these dots into this circle, right? So the liter is larger, but the number 1 is smaller, okay? And vice versa for the milliliter. The milliliter is smaller in size, larger in number. All right, so that's one of the ways I keep in my head whether or not I'm going the right direction. If I am converting from a gram to a kilogram, but my answer in kilograms comes out to be larger than my answer in grams, I've done something wrong, okay? Because if you convert grams to kilograms, the grams will always have a larger value, right? They're essentially the same size. I'm just expressing them in different. As far as my mass of pile here is the same weight, but if I express it in grams versus kilograms, the number value will be much larger. Okay, so that's how you kind of keep it straight, which way you're going. Let's do some practice. So I'm going to clear this. All right. Next up, let's do 0.064 milliliters to liters. Okay. So this is what I was talking about there. Milliliters is a very small unit of measurement. If I'm going to go to a bigger unit of measurement, then my number should get smaller. Okay? So I should expect that the answer in liters will be much smaller than 0.064. Okay? Let's do it. First, I want you to write the possible conversions that you're going to use. Okay, so a 1 liter is equal to 1,000 milliliters, or 1,000 milliliters over 1 liter. Okay, so now do the same thing. Decide which one you're going to multiply by to cancel out milliliters. We're going to choose this one. Okay, and now we'll do the math. 0.0, oh, too many. 64 over 1, all right, include my units, times 1 liter over 1,000 milliliters. Okay, so that will be 0.064 divided by 1,000. Cancel units out. My unit will be liters. Okay, let's do that on a calculator. I should have one ready for y'all. Where is it at? Transition and calculator. Right. Okay, so we said it was 0.064 divided by 1,000. All right, my answer is 6.4 times 10 to the negative fifth. Let me write that here on my pad. Oh, 6.4 times 10 to the negative fifth. Okay. So, if I were to write this out in an actual notation, and I think we've been practicing this, let me clear all of this. 6.4 times 10 to the negative 5 can also be expressed as, let's say, 6.4 negative 5. I want to move it 1, 2, 3, 4, 5 decimal 0, 0, 0, 0, 0. Okay, so let's erase that so you can see it. That is the value of liters. Let me write that in. Liters of 0.064 milliliters. All right. So let me show you that again on the calculator, except for this time I want to do it with scientific notation. Okay? Next problem. How do I get off of that? Next problem. Okay. 0.064 and now divided by 1,000 is also expressed as 10 to the third, right? You see how the answer is the same. So those are the same value. What I also want you to realize, so 0. I don't need to do that. Enter next problem. Hold on. 0.64 can also be expressed in scientific notation. So let's do 0.64. Can I do, I guess I can't set it up. Oh yeah, I can. Hold on. Let's add that. 0.64 times 10 to the, it would be negative 2 milliliters. You see how I'm getting there? I'm doing 0.64 milliliters, but I want to convert that into scientific notation, so I had to move it 2 spaces up. All right. If I move it to the left, it's a negative. So 10 negative 2 there. Negative. Does that work like that? We'll see when I get there. Negative 2. No. There. It's also important that you put your parentheses. If you have a scientific calculator, you need to put your parentheses in the right spot. That could get confusing. So I like to do the parentheses separately so that I have an actual value, and then I just plug that value in instead of having to do a problem in parentheses and then another problem just outside of the parentheses. If you do each problem individually, substitute numbers in, it'll make it simpler and you'll make less mistakes, I promise. All right, so 0.64 can also be expressed in scientific notation. So I'm going to do that divided by our other scientific notation, which was 1 times 10 to the third. Let me do that. I'm going to do it all the way out to 10 to the third parentheses. Okay. Now notice that those are the same answers. All 3 of these are the same answers. They're written in different ways. But what I really want you to see is that right here, the 10 to the third, if I move it to the other side and put a negative on it, it's essentially just like adding it, okay? So 6.4 over 10 to the third would just be 6.4 times 10 to the negative third. You get where I'm going with there? Let me do it on my whiteboard. Okay, let me clear that. Clear all. Okay, so let's just use simple numbers. 2 times 10 to the 6 divided by 3 times 10 to the 3. Okay? So now, in order to do this problem, you can do it on your calculator, obviously. But a simple way would just be to move the exponent to the other side. So it'd still be 2 over 3, right? But instead of having all the scientific notations over here, I would just move the 3 to the top, make it negative, and then add them together. Okay? So 10 to the 6 minus 10 to the 3 equals 10 to the 3. Okay? So this would end up being 2 over 3 times 10 to the 3. Let's check it. That'd be 0.66 times 10 to the 3. Let's do it on a calculator and make sure it works out that way. Alright? Transition. Calculator. We said, next part. 2, oh, I gotta do parentheses. 2 times 10 to the 6, right? Parentheses, divided by 3, parentheses. You see what I mean? If you just do that individually, you don't have to worry about that as much. 3 times 10 to the 3rd. Your calculator is also going to be much better than this one. Okay, so that's 6.6667. 1, 2, 3. If I express that in scientific notation, for example, like I did here, 0.66 times 10 to the 3, and enter. Okay? So, that's some ways that you can manipulate scientific notation to your advantage. Alright? You might get a little lost going back and forth. If I flip that notation, I can essentially just flip the sign. So that's going to be a little helpful tip for you doing some of these math problems later on. Let's go back to... Oh, just so you saw where I got that. Remember we said 0.66 times 10 to the 3 was what we had on our whiteboard. Okay? So, that's pretty good. Let's go back to the book and see what else we need to look at. Alright, so those are your conversion tables. We talked about ruling. Cubic centimeter, or cc, is also the same as a milliliter. So if you see centimeter cubed, cc, milliliter, they're all interchangeable. Okay? This talks about volume. Alright? Alright, so this is some of the work we've been doing, being able to convert. And by the time you do the YouTube videos and the Master in Chemistry homework, you should have this pretty solidly. So, yeah, make sure you get on top of this. If you get a good base in this, then the rest of the math is nothing going forward. I mean, you'll be able to handle just about anything if you can really get a solid foundation on these mathematical skills. Okay? Because that's all it is. We'll give you an equation and you just have to do the math. And if you can set up the equation so that it's easier for you, then you're going to get to the right answer. You're just going to do a much better job if you have some safeguards that keep you from making mistakes. And that's what some of these methods are. They're just safeguards to make sure that you're canceling out, you're dividing by the right number, you're going in the right direction for measurements, right? Your number is getting bigger as your unit's getting smaller. Percentage, yeah. Density. Okay, so density is going to be another one of your videos. I'll let them go into detail on that. But density is really helpful in chemistry and most sciences. Biology, I also have a biology major. Density was very important in toxicology and ecology. A lot of stuff in the environment we need to know. Densities, atmosphere, which is essentially your air pressure. Um, but these kind of multiple units, right? So like density is a gram per milliliter. You'll see this a lot where we have to use two different units to make characterizations about substances or molecules in chemistry. And so you'll see a lot of that. And that's why I said it's important that you always use metric units, because when you're converting from one to another, if I say, like I said, if I give you a kilogram, you'll need to convert that into gram before you can give me an accurate density. I may do it on both sides. I'll give you a kilogram and then I'll give you in liters. So if you're going to get it to grams per milliliter, you'll need to convert all that. Although I think kilograms per liter would actually be the same thing. Yeah. Anyway. All right. Let's see. Specific gravity. It is related to density. It compares the density of a substance to the density of water. And you also see this is a very standard practice in chemistry as well. So we'll use water, for example, 1 cc, which is 1 gram per milliliter. Also, or excuse me, 1 cc is also 1 milliliter. But the density of water is 1, and that's based on the weight of 1 milliliter of water. We came up with these units based on water because it's the universal substance of life. So it's used in everything. That is our standard. Everything is compared to water. When we get into gases, the standard is hydrogen. It's the first element on the periodic table. So everything is compared in relationship to hydrogen. So specific gravity is a measure of the density compared to the density of water. All right. Some more practice problems. Oh yeah, I did want to go through here more slowly so that people that didn't have a book could use this video instead. So I'm sorry about that. I'm going to kind of go back to the top, and I'll go slowly through and just finish up. So tomorrow we're going to do chapter 3. We're going to actually start getting into chemistry, which I'm really excited about. So yeah, stay tuned for that. We also got the lab tomorrow, which will be hopefully like a full-fledged lab. I imagine it'll take a few hours to do it, so allot some time. All those assignments are going to be due Sunday, as I said. Mastering chemistry, it's hard for me to tell how long it takes y'all to do it. So if you could just, for example, I have some analytics that show me how long y'all spend in the program. But if you start the program, walk away, come back later and whatnot, like it may say like 8 hours, to finish the stuff. And I really don't want it to be that intense. So let me know what the workload's like, if it's way too much, if it's okay. Like if it's only taking you an hour to do your homework, then I think that's fine. I think you're supposed to spend every hour you spend in class, you spend 2 hours out of class. I'm considering these videos that you're going to watch class. So with the YouTube videos and this lecture, I don't think you're going to be at like maybe you'll hit 2 hours today apparently. So I took a little bit longer than I wanted. Starting to feel better though, so that's good. This is a pretty long chapter though. Make sure I move that. Like I said, I'm just going through here. If anybody's still hanging around, I'm just trying to give you an opportunity to look at the book, pause it if you need to. I'm I know some people said they wouldn't get it till they got their funds. So I feel you there, man. I'm gonna try to help the best I can. All right. Let me know if I missed a page too. If you see that there's something missing and you need it, you can email me. All right. Practice problems. I'd also recommend watching, extra videos. If you get all this done, go into Tyler DeWitt, I think is one of the guys that I use, and watch the other videos he has on, I don't know, not scientific notation, but units, unit measurements, lab practices, stuff like that. I mean, the guy is he's pretty good. I used to use him when I was in school. So, all right. I think that's it. Like I said, look out for the videos. So everybody did a good job on that first day. I saw that there's mostly everybody, I think, probably did that first day. Don't let it fall too far behind. I know some people hadn't even looked at the second lab or lecture yet. If you get far behind, like I said, you're going to have a hard time finishing all up by Sunday at midnight. So stay on top of it. Let me know if y'all have any problems. And that should be it for the day. I'll see y'all tomorrow. Peace.